Hello, I hope you're all well. Please introduce yourselves in the comments. I hope that your journey home was not too bad today. I know it was fairly grisly, and I know that you probably got fairly wet. But I hope you managed to get home. It was something like a horror film, I think you'll agree. But I hope that that's all now okay. All right, that's enough of that. Let's crack on with what we need to do. So we're going to have a look at network topologies today. So let's jump in. Say hi in the comments, and let's get going. It'll be a half an hour, so I reckon about 15 minutes of me yabbering away, and then hopefully some quizzing after that. So let's jump in and have a look at the presentation, what we're going to do. So network topologies. This is the thing that you most asked to look at. Let's have a look. We've got, who's in? We've got Sanuka. He's in the house. There we are. Hi, Sanuka. How are you doing? Good to see you. Hi, Manure. How are you? Do say hello so I can welcome you. I hope you got home without being too wet. I got to work today and I was absolutely soaking wet. It was horrible. Network topologies. That's the grand plan. Okay, so who have we got? We've got Pablo. Hi, Pablo. How are you doing? Thanks for coming. Great to see you. There was a point on the A23 today where someone went through a puddle and I actually got so wet I couldn't see anything for about 2 seconds. It was really quite seriously disgusting. Anyway, let's push on. Today, ladies and gents, we're going to look at network topologies, modes of connection, encryption, IP and MAC addresses, and standards. That's what we're going to get through today. So I'll get through this first part as quickly as I can. If you've got any questions, just shout at me. From last week, can anyone remember what's A, B, C, and D? Any ideas? This was going back to the CPU and the registers of the CPU, the ones that are incredibly hard to remember. Let's have a look. We've got Yusuf. Hi, Yusuf. How you doing? Thanks for coming along. We've got Zora. How are you doing, Zora? So this was the thing from last week. I think of all the CPU stuff, this is the one that's actually the hardest to remember because they all kind of sound the same, unless you go and watch my video and figure out how things move from one register to another. Zora, Pablo, Manure. This is good. How many have we got in? Let's have a look. It's all looking very, very good. Oh, hello, there's Luca. Hi, Luca, how you doing? Thanks for coming along. Can anyone remember what these were, A, B, C, or D? Or how about picking one of them? Because I reckon that D's pretty straightforward because that's different to all the rest. And what about the third word? I've got dogs. What about the third word of A and the third word of B? Those are the giveaways there. Any ideas? What could they be? We've got 7 of you. It'll build. We started with about 7, ended up with about 30 last time. So can anyone remember what any of these are, A, B, C, or D? What about the address of the next instruction to be run, or the data that's fetched? Any idea what that might be? It is to do with registers. I'll tell you what, I'll give you the answer. So this is what you need to make sure that you, come on computer, this is what you need to make sure that you've got in your locker the next time. It's this. So the memory address register, anything to do with addresses, the memory data register, that's the MDR, the program counter stores the location of the next instruction that's going to be carried out, and the accumulator, that stores the results of, or the intermediate results of calculations going on inside the ALU, the arithmetic logic unit. All right, let's have a look at today's work. This is all about computer networks, connections, and protocols. And specifically, we're going to look at IP addressing and MAC addressing. And that seems to want to jump around quite madly on the screen. So let's go here instead. So this part here, sit still, there we go. IP and MAC addressing, and we're going to look at standards as well. That was the other thing that you identified that you didn't know much about. So let's have a look at those and see if we can make more sense of those. We're also going to have a look at the common protocols, TCP, HTTP, and so on. And this is about how data is sent and about how data is formatted. And we've got the last 1, 2, 3, 4, which are, let's have a look, the last 4 down there, POP, IMAP, SMTP, and In fact, pop IMAP SMTP, they're to do with email, for how mail is sent. So we'll have a look at those. So you've got some protocols for moving data around, some protocols for moving files around, and then we've got the hypertext transfer protocol, which has got to do with the internet. So we'll get into those to make sure you understand what they are all about. Right, and we're going to look at, we're going to look at protocols, that's fine. Right, 5-minute teach. Let's start off with IP addressing. IP is Internet Protocol. So that's the first thing. That's what it stands for, is the Internet Protocol. So it's how data is sent across the internet, across a network. And it governs the format of data, so how data is compiled and put together, and then how it's sent between TCP and IP networks. TCP, Transfer Control Protocol, and IP, Internet Protocol. So IP addressing, typically in the exam, they're going to want you to come up with a couple of facts or be able to recognize IP addressing from MAC addressing. That's usually where this piece of work resides. So first of all, what can you say? The IP address is a unique address. However, it can be changed. You can change your IP address. So if you think about, you can group IP addresses together, for example, so you can group your printers together and your computers together. And you can also use a VPN, a virtual private network, to spoof your IP address to pretend that you're in a different country. Say if you want to access, I don't know, film or music or anything from a different country. Because sometimes they put in restrictions to make it only available to, for example, bbc.co.uk. If you try and watch any BBC stuff from France, you can't access it. They'll try and charge you for it. So you'd need a VPN for that, because it'll spoof your IP address and it'll make the BBC service think you're in the UK. All right, so not that I suggest you do it, clearly. So a unique address that identifies a device on the internet or a local network. It's an identifier, it's an address, and it allows data to be sent between devices. I mean, in the simplest possible way, if you're sending data, you need to know where you're sending the data to, and that's what the IP address, that's how the IP address works. It's a string of numbers. That's the other thing you can mention, that it's a unique address that identifies a device on the internet or a local network. It's a string of numbers separated by full stops, 192.6.something else. It's not linked to hardware, and that's the sort of one of the important things here, because a MAC address is linked to hardware, and it's either 32 or 128-bit binary number, and that depends on which IP addressing you're using. More on that later on. But those are the key takeaways, and typically in the exam you'll need to pick out maybe 2 of those, or to recognize 2 of those as being IP, as opposed to this one, which is the MAC address. So MAC addresses, the key difference is MAC addresses are hardwired into hardware. They can't be changed. So once a MAC address is assigned, that's it. It is there for eternity. That is the address of that device. So again, it's a unique identifier like an IP address, but it's hardwired. It can't be changed. The MAC address is a 48 or 64-bit binary number, and it's then converted into hex. Now, this is used by the Ethernet protocol. The Ethernet protocol is the one that we use at school to send our data around the network. And that Cat6 cable, the one with the little nibbly bit there, who have we got? We have got Mohammed. Hello, dear boy, a bit late to the party. Turn the mic up. Is my mic too quiet? Are you struggling with it? It's looking like I've got something, looking like it's okay. Is that any better? Is that a bit louder for you? Let me know. So the difference is it's used by the Ethernet protocol on LANs, which is local area networks. It's a bit quiet, is it? Okay, I can dial it up here. Hang on a second. It's showing good levels to me. That's too loud. How about that? Is that more or less where it should be? Let me know. Is that loud enough? Is that a little bit louder now? I hope so. If not, marvellous. I think beautiful could be stretching it. I've been called many things. That would be a stretch. So MAC addresses are used by switches to direct data to the appropriate sources. Cool, thanks guys. So listen, it can't be changed. That's the key thing. So your brilliant. Your mobile devices. Hi Josh, how you doing? Hi Dom, how's things? Good. I'm glad you can hear me. So MAC addresses can't be changed. They are hardwired into the device. So your PlayStation, your phone, they've all got a MAC address, all right? So that's the difference between MAC and IP addresses. So learn a couple of those so you can describe the difference between them. Right, then we get to standards. It's funny, so many of you said I don't understand standards. In a minute you'll go, oh, okay, that's really quite easy and quite boring. So standards are simply an agreed way of doing things. And in fact, I invite you to cast your eyes over the last 1, 2, 3, 4, 5 things there. MP3 is a standard. Bluetooth is a standard. Ethernet's a standard, so is TCP, IP and HTML. So in other words, it can be used across many devices. It's a set way of doing things. Because clearly, if everyone made, so think about MP3s, right? I mean, there are different formats for music files. Apple do one called AAC, and there are various lossy and lossless formats, something you'll need to dip into on another day. But it's an agreed way of doing things. So if everyone makes their music files in the same way, it means that when people create devices, they can ensure that they play the right format. Because as you know, with video, there are loads of different formats of videos. You've got MPEG, you've got AVI, which is the lossless format. You've got dozens of different formats, and all of the different companies use different formats. Whether it's MP2, like DVDs are MP2, for example. And I mean, YouTube supports quite a few, but it's more difficult when people don't agree on the standards they're going to use. So listen, the key takeaways are, in terms of the exam, what's the benefit? A, what is it? It's a set way of doing things. B, it makes it simpler to build software because it means that everything's going to be using the same standard. And it means that things can work on different platforms and different systems. If you think about it, what are platforms like PlayStation or an Xbox? Different platforms. Windows and Mac, they're different platforms, as well as being different systems in the case of the PlayStation and the Xbox. So you get wider compatibility. Easy for me to say. That's one of the bonuses. And then it's easier to collaborate, to work together with people when everyone's using the same standards. So I hope that makes sense. Standards are pretty straightforward to understand, really. I mean, for example, a 3-pin plug in the UK is a standard. If you go to China, you get the 2-pin plug like this, or that way. Let's not abuse you. They've got the same thing in mainland Europe. They've got a slightly different 2-pin plug in the USA. By the way, Bluetooth. Exciting fact, right, is that Bluetooth, the name, comes from a Norwegian king, King Harald, who had a blue tooth. His tooth was rotten, and he brought together Norway and Denmark. And so bringing things together, that's how Bluetooth got its name. It was actually a working name until they came up with something better, but in the end they stuck with that. So there we go. Totally irrelevant, but quite interesting nonetheless. Right, protocols now. So we've done standards, we'll look at protocols now. Here's the takeaway. It's a set of rules that allow devices on a network to communicate with each other. And that's it. So protocol is a standard way of doing things. And we're going to go, Mayhard, how are you? He had a Bluetooth because he had a Bluetooth because his tooth had died. And when your tooth dies, it goes blue, but the tooth hadn't fallen out. So his tooth was still in his mouth, but it was blue. So he had a dead Bluetooth. Yeah, I don't think dentistry was up to very much in 859. I think you suffered with the Bluetooth rather than risking someone taking it out. I think dental surgery is something that could often end in death. If you ever get the chance to go to the dental museum and see the tools they used, you wouldn't go to the dentist. So protocol, standard way of doing things, and it again allows cross-platform, cross-device compatibility. And protocols is really more to do with software. So let's jump in now and have a look at some of these different protocols. Let's start with this one. It's interesting because in JE276, the spec that came before yours, you had to learn all about data transmission, about TCP. And actually, I think it's a shame they dropped it, because it's really quite interesting how it works. So TCP/IP, this is two sets of rules working together, right? You've got transmission control protocol and you've got internet protocol. And this is all about how data is sent across a network. So TCP and IP, and this is within the layer system. These sort of ideas of these abstract layers, and you've got the layer which is the electricity moving around. At the very top, you've got the user typing things into a computer, and everything is organised along this idea of an abstract layer. And TCP and IP sit on layers that are next to each other, and one bit does one thing, and the other protocol does the other thing. So let's jump into it. TCP, or TCP Transmission Control Protocol. Two protocols, and it governs how data is sent across a network. So in the case of TCP, the transmission control protocol, that's to do with sending data packets. So if you're sending an email or you're sending an image, it gets chopped up into packets. So say it gets chopped up into 20 or 30 different packets, and then they're sent from A to B, because it's much quicker. If you ever use torrent software, it's much quicker to send little packets of data rather than it is to send big chunks of data, because they get easily lost, and if something goes missing, it's a complete disaster. Whereas little packets of data, they move around a network much quicker. But they're split into packets, and they are then sent to wherever they need to go, to where the IP address, because that's how IP addresses come into it, because that bottom part is to do with how the packets are addressed, and it uses the IP address to send it to its destination computer, because the computer has got its own IP address. So the TCP protocol is involved for sending, for splitting it into packets, for reassembling the packets, and the error checking is to make sure that the same number of packets that were sent is the number of packets. So if 30 packets are sent, that 30 packets arrive. Got it? That's the idea anyway. And it either uses IPv4 or IPv6. Now, remember we talked about whether it's how many numbers are used to represent the IP address, and that depends whether it's IPv4 or IPv6. And they've had to go to IPv6 because the number of addresses required globally has exploded. If you go back to the olden days, when I first had a computer, people would have maybe one device on the internet, whereas now, I mean, I've got 5 or 6 or 7, so you need loads and loads and loads of addresses. All right, so that's TCP/IP. You might find it useful to go and Google TCP/IP and actually look at how that works. You don't need it for the exam. All you need are those facts that I've put on the board that I've put on the at school that I've put on the screen there for you. That's all that you need to actually understand this part. What time are we at? What is the time? 47. I'll get a move on. HTTP, Hypertext Transfer Protocol. This is all to do with web pages and how the text and the images and the sound on text pages. In other words, everything that's on a text page is sent across a network, okay? So that's what HTTP is about. Take that second bullet point, defines the format of data and commands used between web server and browser, okay? So that is, what type of question has TCP in it? Okay, so they might ask you what TCP stands for, and they might give an example. So hang on, let's go back to here, because that's a good question. Let's go back to here. So they might say which protocol is concerned with splitting data into packets, or concerned with error checking, or concerned with transmission of data packets. So they can so this sort of, they've got the definition and they've got the name of the protocol. So they can do this quite suits, you know, one of those questions where they put things in a table and they do a tick list and make you say which one's which, or you've got to draw a line from one to the other. So that's the sort of thing they'll do. So make sure that you know what these different protocols do. And if you understand that, then these sorts of questions should be nice and easy. Does that help, Yusuf? Has that answered your question in a sort of roundabout, long-winded sort of way? I hope so. HTTPS is exactly the same as Hypertext Transfer Protocol, except the S stands for secure, so it's encrypted. And don't forget, encryption is, we're up to 18 now. It's good. Don't forget, encrypted means that it is scrambled. It's encrypted. The plain text turned into ciphertext. So if it's intercepted, it's rendered useless, and that fits in with all of the work on prevention of you know, all that work we did on the house we built in terms of making sure that your data can't be stolen and a man in the middle attack. Good. Sir, what's the largest amount of marks you can get on this? Hi, Krish. They could do a 4 to 6 mark question on this. They do like their tick box questions because they're quite easy to mark. And also, students tend to be fairly poor on the protocols. They tend to find them boring. Ziggy, if I built a house, you would never ever want to buy it. But what I did with my class is that I made we built a virtual house inside our head in which we stored all of the different types of malicious code, all of these system threats. I knew it would come to, but eventually, all of the system threats. I will send you out the mind map that we learnt, and you might find that quite useful. Mind Palace. I'm glad someone was listening, Mohammed. I should know. I taught you. We made a Mind Palace, didn't we? I was scratching around for that. So Mind Palace, quite a good way because you've got a silly story of remembering some of this quite difficult stuff to remember. Yeah, Mind Palace. Good one, Mohammed. That's what we're after. So that's HTTP and HTTPS. FTP. This is a protocol that I use all the time, and it's for transferring files. Because obviously, if you try sending a file using email, anything over about 5 meg is a real pain to send. I mean, some servers, some providers and email clients allow you to do 10 megs, but it's slow and painful. So file transfer protocol is used to transfer files across the network. Typically, if you're building a website, you'd use FTP to put all of the images that you want onto the web server. You can use FTP for that. So CyberDuck is an example of an FTP client. So literally, you load all the files you want in one place, you put in the address you want it to, and it just pings them there. But it does it really efficiently. May need username and password, and it's used to upload web pages to a web server, and it can be used to share files. So FTP, File Transfer Protocol, does exactly what it says on the tin. It's for transferring files. Okay. POP, IMAP and SMTP. This one often confuses people, and this is all about email, about sending messages. So back in the olden days, the protocol, and don't forget, this is just a set of rules that's written so that the data is sent in a certain way. Because when you send an email, you're just sending data to someone else, to an IP address, aren't you? That's fundamentally all that you're doing. So POP, the Post Office Protocol, are the rules for receiving emails. And the emails are downloaded to the client server, to you, and when you do that, the emails are removed from the server. Now, POP was the original system, the original protocol, but it's not actually that great because increasingly people have lots and lots of devices. So it means that if you download something on your phone, then it's not on the server anymore, so you can't access it if you want to do it on your laptop, which is where IMAP became really popular, because that third point with IMAP, where I've got emails remain on email server plus sync, it means that you can synchronize across devices. So you can use lots of devices to access the same emails, but they will remain on the server. So IMAP is the current one that people use. POP is very old-fashioned and it's been phased out really. And then we've got SMTP, which is Simple Mail Transfer Protocol, and these are protocols, a set of rules for sending email. So those are your 3 email. You've got 2 for receiving, for downloading from the server, and you've got 1 for sending. Okay, and the difference is that with IMAP, the messages remain on the server, and you can sync across devices. And for POP, they download. You download them, and that's it. Are we going to cover this in class? Yeah, I think we probably will have time to cover this in class. I mean, we're trying to get through as much of this as we can before the real exam. We've got time at the end to do revision for this. And I mean, also, you'll notice that I'm trying to rush through some of the stuff that we're doing now, so that we've got more and more time to revise for the exam itself. But these are just facts that you need to learn. Right, it's quiz time. So let's have a go at this and see how you do. Which is MAC address? What's the definition? And Yusuf, your question, what sort of questions will they ask? These sorts of questions. So they might do a, they love a bit of a table where you've got to tick things. So what would you say for MAC address? Is it A, B, or C? What do we think? Fingers on buzzers. Well, you haven't got buzzers, but just type in A, B, or C. What do we think, ladies and gents? Sanuka has said C. Yusuf has said C. Why can't I click on your things? Oh, come back. So hang on. The first in was Sanuka, who said C. Yusuf said C. Mohammed said C. This is all looking very, very positive. We've got Mohammed said C. Lucas said, yeah. So listen, guys. We've got Dominico who said C as well. Pablo said C too. So let's push on. You are absolutely spot on. The answer is C. How about this one? IP addresses. What do we think? What do we think about this one? And by the way, Manua, you were right. Chris, you were right. Josh, you were right. Kay, you were right. And Sanuka was spot on. So what do we think about this one? IP addresses, A, B or C. So this is the sort of level of detail you're going to need to know. How long have I got? I've got 5 minutes. We'll push through as many as we can. First couple of answers, guys. IP addresses, what do we think? Yeah, good man. Good. We've got Chris who said A. We've got Mehar who said A. We've got Luca who said A. We've got Tiger. Hello, Tiger. Welcome. Who has said A, who I can't click on because he keeps trying to escape from me. There we go. Sanuka A. Josh A. Pablo A. Okay, so let's have a look. Are you all correct? It's C. IP addresses. A deal with the format of data when using TCP/IP. So a bit sneaky. So I'll give you a ding. It's TCP/IP, not just TCP, because the two work in tandem. What about this? This is the exciting game of guess the answer. Sorry, the exciting game of guess the question. This is the answer. So what was the question? This, by the way, is a past paper question. So defines rules for data transmission, defines standards for data transmission. What was the question for this? Because it was TCP/IP. It was TCP, Yusuf, but it was TCP/IP. That's the protocol. And in computer science, we have to be accurate, don't we? Remember all the red pen I put all over your paper? Pablo is saying C. That was to the previous one. He knew it. Yeah, Luca, I think you're right. I think we should blame Krish. I think that's quite reasonable. What do we think? What do we think the question is here? Any idea? 4 minutes left. 4 minutes left. Come on, guys. What do we think? We've had 36 people here so far, which is pretty good. 36 is a good number. What do we think about this one? What's the question? Shall I put you out of my misery? Oh, hello. What does TCP thing mean? Oh, I love to use the word thing. You know, I like a random thing in my questions. Let's have a look. I think Mohammed. I think. It means, it says define what's meant by a network protocol. Okay, so that was what they wanted there. How about this one? Guess the question. So this is the answer from a past paper question. What do we think? Wireless transmission is slower than cabled. More devices use... In fact, I've not done that one, so let's push on, not do that one at all. That one was... I didn't cover that today, so... Oh, get off. Let's do this one instead. What does HTTPS stand for? Here we go. Here we go. What do we reckon? What does HTTPS stand for? I didn't play you my quiz time song neither, which is very upsetting. I can't even find it. What do we think? What does HTTPS stand for? Ooh, hello, the answers are coming in. We've got I think, Tiger with C. We've got Sanuka with B. We've got Mohammed with C. We've got Mehar with C. We've got K with C. We've got Zainab. Hi, Zainab with B. We've got Sanuka with C. We've got Ziggy with V. We've got Manur with C. C, B, C, B. I've taught you well. You're all massively confused, aren't you? Should we put ourselves out of our misery? HTTPS stands for... Wait for it. Come on, computer. Could you please just work? It's quite enjoying just not working. Come on, computer. Here we go. Come on. There we go. Hypertext transfer protocol, secure. It's the secure. Bees, how many of you got it right? So Sanuka's hedging all his bets here with ABC. Honestly, I have to look at what you've got here. So let's go on to this one. Which two of these protocols, this is the sort of question they'll ask, which two of these protocols deal with email? I've got 1 minute left. If we do one more perhaps. Interesting. Secure doesn't make sense. Secure makes sense in the context of it being safe because it's been encrypted. Okay, the data's been the data that's sent. So you know when you buy stuff in using your credit card, it'll say HTTPS, so it's secure because your credit card information is encrypted using 128-bit encryption. Yeah. So that's something you'll come across when you buy data. Oh, people are coming in. We've got Luca A and B. I think, did Pablo come in with something? Oh, you've been doing this when I've been jabbering. A and D is twice for you. We've got Luca with B and A. We've got Zainab with A and D. Krish D and C. Pablo A and D. Luca A and B. Yusuf B and A. A few more. A and D for Mehar. We've got Dominica A and D. We've got Mohammed A and B. Manoa A and D. Well, we all seem to agree on A, don't we? Shall we see what the answer is? It was A and D, which most of you got right. So I shall reward you with a ding, and I think that possibly a round of applause. And I think that we have done until 7 o'clock. Guys, we've got through what we needed to do. I've got a few more questions there, but we can go through those in class, and I'll send those off to Miss Green and Mr. Muller, so they can also finish those off with you next time. So we've got one of these next week. Who's here? Oh, there's more people coming. Let's have a look. Who's this? We've got Hayden, who's come in as well. Hi, Hayden. We've got Ziggy, we've seen. We've got, okay. So I will make a copy of this now. I'm going to cut out all of the stuff. Well, a little bit late to the party. I mean, everyone's gone home and they're clearing up, to be frank. I mean, but, you know, what can we do? So Hayden, I will put this onto YouTube. I'm going to chop it down and get rid of all of the waffle with me jabbering at the start and jabbering at the end, and that'll be on there in an hour or two. I will send you a copy of this PDF so you have it, and I would say that the key thing for you to focus on is to go away and learn these protocols and make sure that you're happy with the definitions, because this part of it is all about definitions. So make sure that you know the differences between IP and MAC. Can you talk about the benefits of standards? Learn the list of protocols, because they're not that hard. You've got 3 for email and a couple of others. File transfer protocols for moving files. Learn the registers. Outro music. Yeah, do you know what? I should really have some outro music. So I think we'll go for something scary. Guys, it's been an absolute pleasure. And just to remind us of the dreadful weather, I think we should also have some dreadful thunder and rain, and possibly somebody having a bad day. Guys, I will see you all tomorrow. Please try and stay dry, and I will see you tomorrow. Take care, guys. See you next week. Bye, 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 bye.